we'll be solving linear systems of equations by graphing. A linear system consists of two equations. In this example, we have y equals x plus 3 and y equals negative x plus 3. Whenever you solve a system by graphing, it's easier to graph it when it's in slope-intercept form. Slope-intercept form is when y is by itself and everything else is on the other side of the equal sign. The m, which is the slope, is the number that's in front of x. B, that number that's by itself, that is the y-intercept. We can easily identify the slope in the y-intercept when we have it in slope-intercept form. Both of these equations are already in slope-intercept form because y is by itself. So we're going to identify the first equation. Remember, if there is no number in front of your x, there's a 1. There's always a number. So if you don't see one, it's 1. So our slope is 1. But remember, slope is rise over run, which is a fraction. So whenever you have a whole number, put it over 1 and it will be a fraction. And then our b, the y-intercept, is 3. The second equation, our number that's in front of x, is a negative 1. So negative 1 over 1. Then our b is negative 3. So now when it comes to graphing these, remember the b, which is the y-intercept, is where your line hits the y-axis. And then you're going to go up and over by your slope if it's positive, and then down and over by your slope if it's negative. So now we're going to graph. The first equation, our b is 3. So we go to the y-axis to 3, plot a point. Then our m is 1 over 1. So from this point, we're going to go up 1 to the right 1. This is our second point. Connect those two, and this is our line. Our second equation, our b is negative 3. So we go down to the y-axis to negative 3 and plot that point. Our slope is negative 1 over 1. So we're going to go down 1 and then still to the right 1. That's our second point. Connect those two, and this is our line. Now, some students get confused when it's negative. Remember, going down is negative, going to the right is positive. A negative over positive is negative, and that's what we want. But some students like to go down and to the left. Going down is negative, going to the left is negative. A negative over negative is positive, so that will give us a positive slope. So always just a rule of thumb, if it's positive, go up and over to the right. If it's negative, go down and over to the right. So always just go to the right. And so our answer is where the two intersect. They both intersect here at the point negative 3, 0. And this would be your answer. Okay, the next problem are two equations. We have y equal negative 2x plus 3 and 4x plus 2y equals 6. This one is in slope-intercept form, but this one is not. So we don't need to change anything with this one, but we do want to get the y by itself here. So whenever you're trying to get a variable by itself, anything that's on the same side of that variable that is not that variable, you're going to move it over to the other side. So for this equation, we want to move this 4x to the other side. It's positive, so we subtract. The 4x's are going to cancel here, and we subtract it over here. And we get 2y left on the left side. And then remember, you want it in slope-intercept form, so you want the x first and then the number. So negative 4x, this is a positive 6, so plus 6. Y is still not by itself completely. 2 is multiplied by y, so now we're going to divide everything by 2. And when we do that, we get y equal negative 2x plus 3. Notice that both of these equations are exactly the same. They are the same equation. Therefore, when we graph it, it's going to be one graph. They have infinitely many solutions. So here our m is negative 2 over 1. Our b is 3. So we go to the y-axis to 3, plot our point. Our m is negative 2, so from this point go down 2 to the right one. Connect those two. This is our line. And since both equations share the same line, our answer is infinitely many solutions. There are some cases when you have two lines that are parallel. When they are parallel to each other, the lines will never touch. And when they are parallel, there is no solution because they never intersect. I hope this video was a help and you understand solving systems by graphing a little better. If you have any questions, please see your instructor.